Today we're going to be specializing around service meshes. So talking today, coming up first, we've got Saiyam, our Director of Technical Evangelism, giving an introduction to service meshes. Then we've got Kai, who's a developer advocate at Civo, talking about the SMI, the service mesh interface. And finally, our guest speaker, we've got Jason Morgan from Buoyant, talking about adding an ingress to your service mesh. So I shall stop sharing and hand over to Saiyam.
So hello everyone, I hope you're able to see the screen. And so today we'll be discussing on introduction to service mesh. So if you ever wanted to know just what service mesh is, or it has been on your mind for a while, like okay, we have seen a lot of service mesh, but what it actually is, why do we need it, what are some of the key things that it tries to solve in the Kubernetes ecosystem and otherwise. So I'll try to break that down into simpler terms, and we'll make sure that I try to make the service mesh introduction simpler. So before that, yeah, just my introduction. You can reach me out on Twitter at Saiyam Pathak, and I work for Civo as Director of Technical Evangelism. And yeah, I have my YouTube channel as well. You can go check out some of the live streams that I do and some of the meetups that are organized. Yeah, all virtual as of now, but I used to organize a lot. And yeah, I'm CNCF ambassador as well. So let's begin. Want to begin with the plain microservice architecture, basically. So we all know that there has been a shift from the monolithic architecture to microservice architecture. Now, in microservice architecture, you can think like the application is broken down into chunks of microservices, and each microservice plays an important role. And on a whole, when all of these microservices connect to each other, they talk to each other, there is a complete workflow process. Just say that you are signing into a bank portal and you log in. So there is a login microservice for that. And then there's authentication microservices that authenticates your credentials. And then you visualize your account balance and some of the other things that can be another microservice. So on, you can consider like all of those pieces now are broken down into the microservices, but they are communicating with each other. Now, all these communications, like let's say S1 is communicating to S2, S2 is communicating to S3. So this is a microservice architecture. Earlier, when the applications were small, so there was not much problem. But as and when we are talking about scale, we are growing in the terms of microservices, and even people are talking about nanoservices, even smaller microservices. So all these things getting into place and making it at scale, there are problems that arise. Now let's talk about those. Now, why service mesh can also be like, what are the problems that are there in the current microservice architecture? So first, obviously, is the authentication. So when you talk about a Kubernetes ecosystem, all services can talk to each other. So there is no authentication mechanism pre-built, like this service can talk to the other service, and they can talk to each other within Kubernetes. Now, obviously, as a developer, you can integrate your own authentication mechanism. That is doable, but that excludes your business logic. So you will not be focusing on actual business logic, which will be the functionality of the application. Second is the service call failure, which can also be like service A, which in the previous diagram you have seen service A, service 1 calls to service 2. Now, if that fails, there has to be a retry mechanism. So now those set of mechanisms also has to be coded. So you can obviously a developer can code that, but again, it's separate from the business logic. So there is a retry mechanism that you have to implement. Now, again, the retry mechanism can be you are retrying how many number of times, how many retries are safe, how many retries are not safe, whether the retries will create more problems or will create more load. Sometimes that happens. And so all these things have to be coded in a logic. So you can see how the code is getting bigger and bigger for each microservices. Then is traffic splitting. Now that also becomes like, if you want to split traffic, you have a new version, or you might have heard of canary deployments. So you have to split the traffic between two services. Again, you have to have a separate business logic. You have to write a separate logic for that, which will be different from the actual application business logic. Then a certificate security for the services. So usually the services will talk on port 80, but you should be, I mean, they should be talking on the HTTPS port. Again, that is additional set of logic that has to be written by the developer. So you have now the idea, like the code is getting bigger and bigger and the problems are getting bigger and bigger. So earlier you only had the chunk of business logic that you wanted to write, but now with the business logic, you also have to write a lot of other things, so that it's a complete secure, isolated with metrics. You have metrics, you have tracing. So yeah, tracing is very important. Now let's say the traffic is going from service A to service B, service B to service C, and service C to service D. So there's a chain of all these services. Something goes wrong. If you do not trace at which particular point the failure is happening, it is very difficult to debug when you have a lot of microservices. Also, network slowness. Now you want to see which call is actually taking more time, which microservice is actually taking more time. Then also the tracing plays a very important role. So that also, if you're not using like the service mesh kind of architecture, so that was still something which a developer has to take care of. So all these things, the cloud native ecosystem has developed over time, and there's a big, there's a layer that has been introduced, which is a service mesh layer. It is actually a layer, I would say, because it is a complete layer that will be solving all these issues without even changing the architecture of the developer. So developer won't need to change the actual architecture of their application, but still can leverage all these features. So service mesh is basically service to service communication using sidecar proxy. We'll talk more about the sidecar proxy, what it is, how we can inject that using the config file. So every feature that is on the left hand side of your screen, which is authentication, service call failure, traffic splitting, MTLS, metrics tracing, they are configurable as a file. So you have a YAML file that where you can configure, and you can use any of the features that you want with respect to the service mesh that you are applying. So you will be getting all these benefits out of the box. So that's, I hope you get a rough picture like why we actually need a service mesh. So that's it. Now we have a lot of service meshes, but the common components in the service meshes will always be the control plane and the data plane. So the data plane will be actually the proxy, which is injected in the application that does all the heavy lifting. I will show you in the next slide what it actually does and where it actually resides in the Kubernetes ecosystem. The control plane component actually is the data plane coordination, like how the proxies are getting injected and all those things, how the service discovery, all the TLS of that, and the metrics aggregation. So control plane will be responsible for that aspect. So talk about any service mesh. You can talk about STO, Linkerd, console, and a lot more service meshes. So they'll be having basic control plane and data plane components, which will be there. And they'll be having a sidecar proxy, which will be injected into the pod. Now, obviously, the proxy also can be different based on the service mesh that you are trying to use or implement. So this is the sidecar proxy. Now, this is the whole game that is getting played within the Kubernetes architecture. So you see here, you have the application. So this is the app, and this is your pod. So in pod, you have a container, which is your application container, which you have been running. Now, what happens is service mesh will inject a sidecar proxy. Now, this proxy can be Envoy, HA proxy, Linkerd proxy, so different based on different service mesh. And the proxy communicates between the services. Now, earlier service 1 was directly communicating with service 2. Now, service 1 will communicate to its sidecar proxy. Then from this sidecar proxy, it will go to the service 2 sidecar proxy, and then it will go to the service 2. Now, this particular thing will manage all the authentication. So if there's certificate rotation, that will be taken care by the proxies. If there is metrics, that will be there. All your tracing, metrics, observability, all these things will be taken care by the sidecar proxy. So the proxy will generate the metrics. And on your side, on the developer side, when I say there are no architecture changes, so that's what I was telling you in the beginning. So you can use the power of service mesh with no architectural changes, and you can deploy it on your system as a layer where you have the control plane and the data plane. It will inject sidecar proxy into all your pods where your applications are, and it will start doing all the functionalities that you have configured while installing your service mesh. So that's pretty much it, like how the service mesh works and how you have the control plane, data plane, and how the sidecar proxy works. So let's move to the next one. So these are the different service meshes. Obviously, there are more coming up, and I have not listed all of them. But Istio, I mean, it's a very popular one, the most feature-rich one, and on the other hand, most kind of complex one as well. So it can be used, for Kubernetes and non-Kubernetes workloads as well. Linkerd is kind of moving towards simplicity and increased performance, kind of lightweight, you can say. And yeah, it's basically built on top of Kubernetes, so it's very Kubernetes native, so you can say the cloud native thing of doing things. Then you have HashiCorp console, you have AWS app mesh, traffic mesh, which is from which is earlier used to be called mesh, but now it's traffic mesh. Then you have Kuma, then OSM, which is by Microsoft, and it is complying the SMI spec as well, which Kai will be talking about. So these are the set of different service meshes that you can use for your application, and each of them will give you all the powers that we discussed, plus or minus, but overall they will be solving the same common goal with different types of proxies that we'll also have a look at. So SMI is obviously, it will be covered by Kai, but it is kind of the API. So people are now, like, you have your other interfaces. So these are the interfaces that the service mesh, service meshes are actually implementing. So there are the interfaces, and all the service mesh are implementing that and complying to those interfaces. So let me show you the service. So this is a very good blog on service mesh comparison. It's kind of a tongue twister, but yeah, service mesh comparison. So you, like, all these service meshes are given, and like how to choose them, all these things. And here's the comparison. Like I was saying, you have the service proxy, which is the sidecar proxy that gets injected as a sidecar onto your pod. So you have Istio, and then you have Linkerd uses the Linkerd proxy, and most of them uses the Envoy one. So Envoy proxy is something which is there, and widely used in most of the service mesh. But yeah, people have implemented, obviously, if you have to do something more lightweight, more kind of Kubernetes way, then you have to make some changes, and that's what people are doing with their own service mesh, and coming up with new solutions that are more lightweight and not heavy to run, and solving all those problems that were there. Also, like Kai will be coming more in the SMS spike, like how they are standardizing the whole service mesh ecosystem. And yeah, I mean, you can see all the advantages and disadvantages. Like it is highly flexible, but at the same time, Istio is also complex. So Linkerd is deeply integrated with Kubernetes, but it is more for performance and usability, ease of use, and all those things. So like this, there is a good comparison that you can have a look at. But overall, the goal of this particular session was, like, you understand the concept, like why service mesh is needed, what are the basic problems that it is trying to solve, and where it is helping the developers to write only the business logic, and not the networking layer, and that is taken care by the service mesh, but whatever that you are choosing to implement for your system. So also this is the Envoy proxy. Like you can go through the documentation, like what the proxy actually does, and why Envoy, what all service meshes are using it, what are its features of gRPC, observability, load balancing, how it does all these cool fancy features. And yeah, it's obviously a CNCF graduated project, so it is matured enough to be used across the industry. Now coming to Civo, so you might have know, like, we have a marketplace where we can install a lot of cool applications. So we have a Linkerd application with a lot of plans, actually. So this was the first one that we did with detailed kind of plans. So you have your minimal with Jaeger, and with the dashboard, and with all of those. So I think that is pretty cool. We have mesh as well. Istio is also there. There is some work which is getting it done to fix, but again, Istio will also be there very soon. And yeah, I think we are having service mesh, but like I showed you, there are other service mesh. So if you want to contribute some of the other service mesh, or you are using some of the other service mesh, then definitely contribute to the marketplace. It is open source, so you can contribute there, and we would love to have more service mesh, because our user base is it's community driven. So people tend to use different service mesh based on their needs. So you can have we would love to have that on the marketplace. So, yep, I think that's pretty much it that I had for the service mesh. Hope you got some idea of what service mesh is and why to use them.
We've got a few questions, Siam, which maybe you'd be able to answer. So the first one from Jithu is, can you share some examples where we need TLS communication between service to service in an internal Kubernetes ecosystem? Doesn't it have latency of encrypting and decrypting for each call made?
Yeah, so like I took the example of the banking system. So there can be some secure applications where you do not want to expose anything or any of the user data due to some compliance issues or things like that. So like the user things. So if anybody the attacker gets into the system, then there should be everything should be encrypted. Everything should be all your communication should be secured, so that all the information remains secure, because not always you'll be running simple applications inside the Kubernetes cluster. People are moving their enterprises with a bunch of microservices, and these microservices also grow at scale. So that's why, I mean, that's kind of one of the things that came directly to my mind. There can be other use cases as well for having the TLS things.
I'm just going to jump in here quickly while if you guys look through another one. Shatakshi asked, like, they joined a little late, so kind of missed out in the initial part. This is being recorded. It will be on YouTube. And in fact, probably as soon as the session ends, it'll be processed and available on YouTube. So don't worry if you've missed the start of it or you want to go back to any of the presentations, they will be available.
Next question, do we have any tutorials for service meshes?
Oh, there are a lot of tutorials, and I mean, you can go to Linkerd, and there are very much quick start tutorials that you can definitely do that. And I think Jason can talk more on like how to get started with using service mesh in an easy way. So I think it's pretty simple. So there are a lot of tutorials.
Do we have any on civo.com/learn?
Yeah, I think by Jason only.
Yeah, Jason has in fact written a guide to deploying Linkerd from the marketplace and having it split traffic and do things like that.
Fantastic. Can someone share the link to that in the chat, please? Thank you. Are there any prerequisites for Kubernetes to running a service mesh?
No, actually, if you are running a Kubernetes cluster, you can directly install, Linkerd. I mean, you can do a Helm install. So Helm can be one of the, that you might need for installing some of the service meshes, but there can be other mechanisms, like some might have the YAML files that you can directly apply. So I think the Kubernetes itself is enough. Oh yeah, there are some toolings that makes it easy, like Istio Cuttle is there that can help you install. So those things are also there with some service meshes.
Okay, what's the value of using both an API gateway and service mesh?
So I think the API gateway kind of acts as only the kind of load balancing stuff, but whereas service mesh will give you a lot of power of doing things. So.
Okay, fantastic. That's
yep.
The end of the questions. I'll reply to the other ones. It's just about what's Kubernetes. Okay, so at this point, let's hand over to Kai for a talk on SMI.
Cool. Just gonna share this desktop here. Hopefully you can see my slide.
Yes.
Cool. Okay, so as has been mentioned, my name is Kai. I'm a developer advocate / developer here at Civo. And thanks to Siam for the general intro to service meshes. What I'm going to do is use that as a jumping off point to talk about the service mesh interface and what it is. And unlike Siam's handwritten slides, mine are going to be boring old presentation slides, but hope that's okay. So what we'll cover today is basically just some definitions, the scope of SMI, what it's actually intended for, developing with the SMI, the service mesh interface specification in mind, and how you can get involved in sort of things around both the SMI and the wider service mesh cloud native landscape. So some definitions first. The SMI was originally started by a sort of consortium between Microsoft, HashiCorp, Buoyant, Solo.io, and a couple of others. in May 19. It is a CNCF sandbox project since May 2020. And CNCF is a project of the Linux Foundation. And basically what it does is it aims to uniformly advance containerized cloud native technologies without being sort of preferential to any particular company. And they maintain a landscape of projects and technologies, and their relative maturity is reflected in what they're called. And so with the SMI being a sandbox project, it means it's an early stage project. So obviously there are already developed and established service mesh technologies out there. And this sort of SMI is almost like a distillation of all of those things. It's come later, which is why it's effectively slightly in an earlier state. So the spec is just that. It's a set of definitions and standard APIs, like Saiyam mentioned in his presentation earlier, that cover the sort of commonly accepted and commonly understood capabilities of service meshes. And we'll talk about more of those capabilities on the next slide. But the general, it's a very general project. It's not meant to be bound to any particular provider or implementation. So it's a set of sort of criteria and custom resource definitions for Kubernetes, but it's not a service mesh product, and it doesn't aim to be. It only sort of, it's meant to be a living specification which develops and evolves with the changes in cloud native and service mesh technology. So SMI is managed by the contributing team. It's effectively an open source CNCF product. And like I said, just as as service meshes are developing, this develops as well. So it aims to define the core concepts and capabilities of a service mesh. And currently we're at version 0.60. And the core concepts and capabilities that are defined in SMI are traffic policy, traffic telemetry, which is getting data out of your traffic information, and traffic management. These are not the fixed categories. Like as the specification documentation says, we expect that over time, as more functionality becomes commonly accepted as part of what it means to be a service mesh, those definitions will migrate into the SMI specification. So what this kind of thing isn't new. For example, CSI, the container storage interface, there's a couple of other sort of cloud native open projects which aim to define a standard, and how you implement that is almost up to you. So the SMI doesn't want to prescribe to you how to manage traffic in a Kubernetes cluster. They just tell you that these are some of the ways that you can specify these sort of policies.
Just to jump in quickly, Kai.
Yep.
As you mentioned, container storage interface and CSI. If you sign up for our next webinar next month, I'll be giving a talk on how to write CSI drivers. I
was about to come to at the end of this slide, actually.
Fantastic. I'm jumping to plug it as I hadn't had the tip.
Yeah, no, absolutely. So without something like these sort of universal or standardized APIs specifications, developers would have to learn the spec of each implementation separately. So let's say that traffic management and traffic splitting in a product like Istio would be designed completely separately and completely differently to traffic mesh. And that would mean that anybody wanting to work between the two would have to learn the new specification entirely. And what this aims to do is to sort of lay a groundwork and then leave the door open for innovation and new technology. So if you want to work with SMI, most people, if you're sort of doing SMI spec stuff directly, you're probably doing it through an already installed service mesh rather than calling any kind of APIs directly. And this is a sort of screenshot that I took from the Linkerd blog, which uses an SMI spec API to apply traffic management to a cluster and have it serve traffic based on that weighting. And this is the example here was sort of injecting error rates to detect service degradation. So as an SMI user, I write the instructions and let the interface handle it. And so that sort of abstraction takes away having to know exactly how the technology underneath it does the actual work. So you're sort of calling a sort of the app, most likely your service mesh application has an operator that then calls the translates to the SMI sort of specification. Then again, you've also got the traffic mesh implementation, which is in contrast to, for example, how Linkerd does it. So Linkerd has almost like a shim, which sits and translates between Linked's own tech and the SMI spec using sidecar containers. The traffic mesh is a service mesh built from the ground up to consume just the SMI spec APIs. And Kevin Crawley, one of the authors, said that the SMI APIs provided a clear consensus on features that had been widely adopted across the landscape, thus ensuring the engineers didn't waste time addressing limited use cases. So if they were building for a service mesh from the ground up, they knew that these were the things that that service mesh would have to cover to serve user use cases. Obviously, it wouldn't necessarily cover every single use case, but it would be sort of a starting point. And that's kind of what SMI, intends to do. But because they're doing it natively, sort of aiming to have SMI compatibility, they don't actually need sidecars to translate between the API spec and any kind of other technology, because they're building directly to that native spec. So, I mean, this is a very quick overview of a kind of overarching kind of project. It seems a little bit like the community around SMI is maybe slowing down a little bit. And it could be because service meshes are kind of becoming very, very mature in many ways. And so I just wanted to highlight that if you are interested in SMI more widely, and sort of these kinds of standards and standard setting and how you can make sure that your whatever project you're working on sort of complies. There's the SMI channel on the CNCF Slack community, which you should absolutely join. They also do community meetings. They haven't had one this month. They're meant to be weekly, but I think they're due one end of this month. Plus then, and this is something that came up when I was talking to Jason yesterday, and Jason's coming up next, is if you're interested in SMI and you want a product to make sure that it speaks SMI, speak to the product liaison people for that product. So, talk to the people who work on service meshes, whether it's, Jason and Linkerd, or talk, find somebody from HashiCorp if you're interested in how Consul does, sort of interfaces with SMI and ensuring that it continues to do so. That's a kind of surefire way to make sure that these projects are aware that there is demand for this kind of standardized overarching set of standards, because otherwise there's I guess a kind of danger, maybe not a danger, but like I said at the very start, it's intended to be a living, breathing kind of standard. So without, it would be a real shame if the SMI sort of stayed stagnant and all of these service meshes went their own different ways, because that would then mean that as developers, you would have to learn more and more new technologies rather than knowing that there is a certain applied standard. So yeah, that's I'm happy to talk more about this in Q&A, but this was just a quick sort of 10-minute run around of the SMI spec. So hope you enjoyed that. Thanks.
There was a question, Kai, on one of your slides. You said about traffic policy, telemetry, and management. Mm-hmm. And someone questioned what's telemetry. Maybe you could just sort of define what each of those three different things are. Yeah.
So telemetry is kind of, it means sort of data from a distance, right? So what you're getting sort of statistics or information about performance. So tele being distance and metrics being things that you measure. So it's understanding things from what's happening inside your cluster, and specifically in this case about traffic. obviously you have, say, data telemetry and disk telemetry, input output operations. So there's all kinds of different metrics that the cluster is potentially outputting, and SMI uses, or defines a certain set of sort of standards to understand that. Traffic policies being things like accepting connections from, only in certain types. So like when Saiyam was talking about using TLS within your cluster. So you can define that you only accept connections between certain services using certain policies. And the traffic management is, so there was a slide that I showed where we could split traffic between two pods, and effectively you can do things like blue-green deployments or canary deployments. These are different techniques of rolling out new versions of an application so that you can pay attention to if there are any errors, any problems that arise before you roll out a whole project wholesale. Hope that covers it.
Okay. Do all popular service mesh implementations conform to SMI now?
Yes, they do. I would say they do. If nothing else, there is a kind of there will be an external sort of plugin almost that makes it be SMI compatible.
And this may be one for sort of any one of the three speakers. So we'll leave the last question until the end, and then hopefully whoever feels best placed to answer it can go for it. Okay, so at this point, let's hand over to Jason for his next talk, please.
Yeah, no problem. So I promised Kai I'd only do the one slide. So I've got one slide here for Linkerd, but if there's popular demand for a lot more PowerPoint, I can provide depending on audience request. So I'm here. My name's Jason Morgan. I'm a technical evangelist for Linkerd, and it's my job to talk to folks about Linkerd and try and convince you to give it a shot and see if it's the right service mesh for your use case. So as part of that, let me just give you a very brief overview. Linkerd itself is an extremely lightweight, extremely fast, security-focused service mesh that is geared exclusively towards Kubernetes, right? So we've been in production over 5 years. We've got a very active Slack channel. I'm gonna ask that y'all, if you're looking at Linkerd, I'm gonna ask that y'all join it, and I'll send you that link in a minute. Lots of stars on GitHub, but if you like the project, we're always looking for more. And we are currently in the CNCF graduation process, and that actually should open up for public comment here in the next couple of weeks. So that's it for slides. Oops. Yeah, there we go. That's it for slides. Here is the Linkerd Slack, so I'll go ahead and put that to all panelists and attendees. If anyone is interested, you can join the Linkerd Slack at slack.linkerd.io, and it's a great place to ask questions or connect with other folks that are using Linkerd. So, end of the slide deck. Everything else is going to be demo. So here I have a Civo Kubernetes cluster, just calling it Linkerd ingress. And actually, let me step back. Oh, Ganesh, you're going to get me in trouble with that one. I'll answer that at the end of this this question period. So I've got a 3-node cluster running in Civo Kubernetes, and what I'm going to show you today is how. I'm going to show you how, and I'm going to talk about why to integrate your ingress controller with your service mesh, right? So different meshes implement different functionality. Linkerd does not include an ingress controller, right? Very specifically, we allow you to bring any ingress controller you want to that environment. Civo Kubernetes clusters, by default, when you install them, come with traffic. So I'm going to do a demo showing traffic, but we have examples using, emissary, I forget Glue's ingress. I think it is Glue, right? The Glue ingress from Solo. Nginx, emissary. I'm sure there are others that I forgot to mention. So that's the scene. The big part is we're going to talk about how and why. And luckily for me, both Saiyam and Kai kind of queued me up because I'm going to show some progressive delivery. And specifically, I'm going to show how you're going to use Flagger to do progressive delivery, how you're going to use a traffic split, and what happens when you do or don't add that ingress to your mesh. Sound good?
Sounds good. We've had a request. Could you zoom your screen so if possible to make your font a bit bigger? I don't know if the terminal is better now.
Yeah, sorry about that. Here's my Civo cluster, and yeah, please keep it up with those sort of comments. I'll try and keep things zoomed in. So here's my terminal. So this one's going to stay a little zoomed out because what I've got here is I'm showing all the pods in this environment, right? So what I have is Linkerd, right? The core service mesh that allows you to, get MTLS between all your applications and get all the other benefits of a service mesh. We also have a component called Linkerd Viz, which is our dashboard. So this allows you to pull up this thing, right? Which is a screen that gives you a view of your cluster, of your various namespaces in the cluster. It allows you to see for clusters that have pods that are part of the service mesh. It allows you to see the success rate of all the requests, the relative number of requests per second in the environment, and then the latency by latency bucket, right? So what's the, what is the tail latency look like on any given space? And right now I have an application. It's pod info, right? It's running. I'm forwarding traffic to it. It's right now I'm just hitting it over HTTP, but I'm going through the traffic ingress to hit this pod info application. And let me zoom in a little bit because we got some important info here. We got two things that we're going to control, right? We've got the background color because we're going to do a blue-green deployment, and we've got what pod we're currently serving off of. And yeah, one last thing. All the things I'm going to be talking about are actually a reference to the Linkerd ingress docs page, which I'll also go put in the Slack, and which will explain in a little bit more depth what we're doing and why and how that works. So on to the actual demo. All right, so in the terminal here, this is the live traffic. I've got pod info running. I can see if I go look at the dashboard, I can see that, I've got the pod info namespace, got a couple components in this application. Specifically, I've got a little traffic generator that I built. I have a Nginx front end, which allows me to surface out my application. And then I have this pod info backend, right? This is the standard deployment of my pod info application. I can see requests, who's coming in. If I go look at pod info, this backend service, I can see that, the front end, Prometheus, the tap deployment, which is a component of Linkerd that allows you to see live traffic, as well as this unmeshed component called traffic, right? Which is our actual ingress in this Kubernetes cluster, right? So traffic is I can see what's coming in from it, but I don't have statistics. I also don't have an encrypted connection between traffic and pod info. Right, so if I were in there listening, I could see the unencrypted calls between these two components. So first off, right, thinking about it as you're looking at Linkerd in your cluster, it's really valuable to just add that ingress to your mesh. So let's do that first and see what that gets us. So I'm doing a lot of copying and pasting here so I don't mistype. But what I'm doing is I'm actually grabbing the traffic deployment from the Kubernetes API. I'm going to output it as YAML, and I'm going to use the Linkerd CLI to add an annotation to this deployment. The annotation is just going to tell Linkerd to insert its little proxy, so we call it the Linkerd2 proxy, right beside that application, have it start handling the traffic from that ingress into my applications. So we see that kick off. I get a warning because I didn't create this in the same way. Obviously, we used Helm to create it initially. And we see the new traffic instance spin up. And now we're going to see is, I'm going to give it just 1 second. We're going to see inside pod info. If I go now look at the pod info deployment itself, pretty soon I'm going to see a new component pop up here, where instead of unmeshed, I'm going to see a little green bar saying, you've got successful traffic coming from traffic. I should pick a different word for it. Successful connections coming from our traffic ingress. We can also look at that by running the edges command. So Linkerd has this edges command, just tells you what deployments are talking to what. You can do deployments, pods, whatever. And whether or not they're currently MTLS. So I can see now traffic is talking to pod info and we have MTLS over that connection. So let's go back to that dashboard and see, there we go. While I was talking, traffic came in. Now I'm able to see like of the calls from traffic, where they go, get full details on all those connections. That's really the excitement there. So right now I've got a lot of what I want, right? I've got MTLS from the ingress, like my gateway into that cluster, to my applications in the mesh, right? Which is pretty valuable. But what we're going to do now is we're going to do some kind of fancier stuff inside Kubernetes. And we're going to talk about why you might want to change the way that ingress talks to the rest of your application. So let's do this. So what I'm going to do is I'm going to modify my customization file, right? So this is how I'm deploying pod info. And I'm going to add in this canary. So this is a flagger construct. So flaggers from the folks over at Weaveworks. It is, I believe, now a incubating product under the DevOps toolkit, right? The Flux stuff, if you haven't seen it. And if y'all are interested, happy to talk about that sometime. So I'm just saving the deployment, and then we're gonna reapply, right? So what I'm going to do here is I'm going to apply with a -K, which is customization, right? I'm going to do a customization deployment of this pod info app, and we're going to add in Flagger to the environment, or tell Flagger to start controlling this pod info deployment. All right. So a bunch of stuff is going to happen. So if you look on the left, there are new pods getting created. There are going to be pods getting turned off. Right. So what happens is I tell Flagger to watch pod info, and what it's going to do is be like, all right, cool. I'm going to have 2 pod info deployments. One for my primary, where traffic's going to go the majority of the time, and one deployment that's only going to hold replicas or pods when there's a change going on, right? And then I'm going to create new services so that I can split traffic from one to the other, right? So let's look at our status. Okay, get canary. Here we see that my canary is initialized, so I've got new objects that got created. So let's check those out. Okay, get deploy. We see that when I initially built this thing, I only created one pod info deployment. It was just called pod info. Now I have 2. I have pod info primary, which has 2 members or 2 pods, 2 containers, and then I have pod info, which now has none. Right, and that's because this Flagger controller is taken over and is making some changes. I also have some services. Right, so new services. I have pod info service, which is how I'm getting traffic to this application. And then I also have pod info canary and primary, right? And let's just do one more. K described traffic split. So this is that standard traffic split SMI spec that Kai showed you right before. So Linkerd implements the SMI interface for traffic split, right? And we do it specifically because that's how Flagger controls its canary deployments, right? So just to reiterate what Kai said, right? Like as you talk to folks that make tools that do cool stuff with service meshes, if you tell them like, hey, like we really like this service mesh interface, we'd like it to be portable, right? Like that's a great place to communicate stuff because it puts a lot of pressure on service mesh implementers to actually ensure that that's in there. Sorry for that tangent. So we've got our traffic split, and we can see that what it's got a main service called pod info, and we're going to call it, if you look at our docs, it's called an Apex service, right? But it just means it's really an empty service. And then there are 2 backing services behind it, pod info primary and pod info canary, and they've got a wait. So right now, all traffic's going to pod info primary. So let's look at that in a dashboard to try and make it look a little bit clearer. And other panelists, if there's anything you want to interrupt me for, if there's a great question I should hop on right away, please let me know. I'm happy to do that as I go.
Can I do that one right now?
Okay.
Okay. Ramiro has just asked, like, specifically to like how much overhead to network and memory does running Linkerd in a cluster add? Is that a concern when deploying it, especially at scale?
All right. So I'll tell you, we believe that Linkerd is genuinely the most performant service mesh you've got out there. So the Linkerd proxy is unique inside the service mesh space because it is written in Rust. So Rust is a language that compiles in the native code, but like allows you to sidestep a lot of memory vulnerabilities. Anyway, long story short, you should check for yourself how heavy it is. We do have some benchmarks that we released very recently. So the folks at Kinvoke a few years ago wrote these benchmarks to decide like what was the most performant service mesh. And Kinvoke, you may know them from the news. They got acquired by Microsoft fairly recently. We went through and we reran their benchmarks earlier this year and here. So I did lie about the slides, right? But we ran the benchmarks earlier this year. They're open source, so you can go ahead and run the benchmarks yourselves in your own environment, right? But we found that Linkerd is really very performant. And the other thing to note, right, even though it comes with compute and memory overhead, right, what you get is you get other things that go faster. So if you're doing gRPC in your environment, right, gRPC does what's called so Kubernetes does connection level load balancing. That means when you open up a gRPC connection, you get one long-lasting connection to one pod, and you send all your requests over that connection, right? Which can actually get slow as you scale out. But if you're using a service mesh, it's able to do, request level load balancing, where it spreads that by request out to all the pods in a backing service, allowing you to go faster. So I know it's a bit of a Weasley answer. The how much it uses is going to depend on your environment, but you're going to be able to see that very clearly inside your Kubernetes cluster. And then you'll find that there are performance gains as you add in a mesh depending on your use cases, right? Like if you're doing a ton of REST calls, well, what we're going to do is we're actually going to upgrade your connection to HTTP2 and then multiplex those requests, those REST requests over that connection. So you're not building up a TLS connection every single time. You're maintaining one long running one, right? Which should, depending on, again, your traffic profile, could be faster than running it without. Did that answer your question? Or I hope it did.
He's commenting on YouTube, so he, I'm guessing he's a little bit delayed anyway. So we're going to assume that he is.
So here's our updated service map. So now that we've added in this canary, now we see that there's traffic going to two places, pod info and pod info primary. So let's look at pod info primary. We can see that it's seeing calls come in from both its front end, right? So the standard way into this application. And I also made a special ingress just to demonstrate this thing where the traffic ingress is talking directly to this pod info backing service. And we can see that traffic is talking to pod info primary, right? Exactly what we'd expect. And again, we get all the metrics about that environment. So now I'm going to show you an intentionally broken demo, right? So let's do our blue-green deployment. So once again, I'm gonna change one of my files here. We're gonna go from blue to green. Right, I'm a fairly literal-minded person. So we're literally changing the background color of the pod info app, right? So what I'm doing is I'm running kubectl apply again on the customization that's defining this whole thing, right? But what I've done is I've changed the background color for this application. So we see two new pods are getting spun up, right? If you see here, there's 0 of 2 pods ready, right? So, or 0 of 2 containers inside the pod ready. So two new pods are getting spun up. And what's going to happen now is, let me just put this here, watch. What's going to happen here is we're using now a traffic split to split the requests coming into pod info, coming into the pod info service between two backing applications, right? Pod info primary and pod info canary. Making sense? Right, and so right now, 10% of the requests are going to canary, 90% are going to primary, and I also have another process in the background that is just spamming the ingress really fast. So what we should see, even though it's a low percentage of requests, what we should see is some of them are hitting pod info canary, right? But we're not going to see that, and I'm going to talk about why here in a second. So with the traffic split going on, we see pod info primary still getting requests. Oh, phew. See pod info primary is still getting requests from traffic, right? Which is good. Sorry, let me get my laser pointer out. Still getting requests from traffic. If we look over at the traffic deployment itself, right, the ingress, we can see that it sees that it has two endpoints, right? Deployment pod info and deployment primary, but it has sent nothing to pod info, right? In spite of the fact that I'm currently looking at you know, about what, 40% of my traffic, zeros come through, right? If I look at the web page, I can refresh this all day long, and I'm staying on the blue background. Also, my pods are all going to be prefixed with pod info primary. I don't see anything that just says pod info, which is what I should see if something is being routed to the other service, right? So I'll just cut through and end the surprise here. What happens is an ingress by default, when you tell it to route traffic to a particular service, right? It doesn't actually send it to the service, like the cluster IP service inside your Kubernetes cluster. It instead evaluates the endpoints that make up that service and sends it directly to one of those endpoints, right? So you don't get Linkerd to do things like a traffic split or a service profile or anything like that beyond give you metrics, you know, support tracing if you're doing tracing, metrics, tracing, and MTLS. That's what you get out of that connection, which is for a lot of use cases going to be enough, right? So, we often want the ingress to make the individual pod routing decisions, right? In this case, that's not going to work for us. So I'm going to show you what we do in this event if we want the ingress to talk to these service mesh constructs, right, on the way to our applications. Still making sense broadly? All right, and please don't hesitate to interrupt me if we've got other questions. So we'll let this deployment finish because I don't actually know how to interrupt it. I'm not actually that good at Flagger, I'll be honest. But we're gonna let it finish. We can see that as part of this canary, right, what it does is once it gets to the top, 75%, it's going to actually scale up that primary deployment so that we have all pods now of the new type. So then we'll have 4 pods essentially that are all now with the green background. And so now if we go look at our app, we're actually gonna start seeing some green, right? Because this is all the blue pods are getting turned off. And then once that's done, we're gonna see 100% of the traffic shifts back to primary, right? It's great, but it's not what we wanted, right? We want the screen to change colors as we're looking at it. So how do we do that? All right, so what I'm gonna do here is I'm gonna re-inject my ingress, but I'm gonna tell Linkerd that it's gonna be in ingress mode. So this pod that we're injecting, or these pods that we're injecting, are going to be ingresses, right? And Linkerd needs to treat them that way. And what that means is now that it sees it, if it gets a request from that ingress with the appropriate headers set, right? So there are some Linkerd specific headers in the request. So if we see those requests, we're going to go ahead and transform them, right? So let's do that. So we see a new version of traffic spinning up. And we're going to look at that ingress object in a second, just so what I'm saying makes a little bit more sense. So I'm going to look at the actual ingress object that we're using here. Is this clear enough, or should I zoom in a little bit? Okay, so I've got the ingress. It's called test. I'm putting it in the pod info namespace. And what I want to do, right, is set the Linkerd destination override for this path. So when I see something come in on the / path on this ingress, the root path on this ingress, I want you to rewrite the host, right, to tell Linkerd to send it to the service for pod info, right, not to an individual pod that the ingress controller is going to pick. And that's going to allow us to take advantage of that traffic split and that Apex service to route things around. All right. Oops, Q, here we go. Oh yeah, and I want to show you the ingress documentation. So again, this is all detailed out right here, right? So essentially what we say is in default mode, right, what we're not gonna do is take over the routing, right? So if you have things like sticky sessions that you want out of your ingress controller, that's still just gonna work, right? There's no change required. If you do instead put it in ingress mode, then all of a sudden Linkerd is gonna take charge of that routing. So use caution and make sure that you're only putting this in the appropriate use case, right? All right, so we overrode that. So let's go ahead and once again, we're gonna update that deployment. Now we're gonna go back from you know, we're in green, but we're going to go to blue. So let's fix that. 1919 FF. All right, so once again, reapply, and we're gonna let Flagger take over. All right, perfect. We see pod info configured. We're gonna see here in a second a bunch of new pods get spun up. Right? Come on. There we go. I've had a lot of demos fail lately, so I'm on edge. But we have our new pod info pods coming up, and let's actually look at this. Let's actually look at this through the Linkerd graph. So we saw some failures from traffic. I guess something happened as we rolled out that deployment, which is fine, right? But it's good to know that as we did it, we had a bit of a hiccup from our ingress. But in a second, we're going to see a new deployment endpoint here. But let's look at pod info first. Just a quick heads up, and we've got some videos on troubleshooting with Linkerd. A quick view, an at-a-glance view of all your namespaces, and the aggregate metrics by those namespaces can be really, really handy in diagnosing application problems, right? So I can see right away, okay, what namespace is having an issue and what is that issue. So let's go into pod info. I see now that, you know, pod info and pod info primary are both serving traffic. I can see the traffic split just like I was seeing from the CLI. I can see it here. I think if we refresh now a couple times, yeah, we're going to start seeing green, blue and green, which is what we wanted to see, right? There's some splitting. And if I now go look at the deployments, I can look at pod info, right? That canary, the one that's holding the pods for the canary service. And we can see that it's now getting traffic, or it's now getting requests from traffic as well. And so that's how we override that behavior. So with the ingress, we're able to tell it to, instead of going to a specific pod, instead, you know, overwrite that and go to the service, you know, that ingress is referring to, and allow Linkerd to make those routing decisions, right? And it's not for every use case. You don't want to be using this all the time, but you want to use it in specific use cases. And some ingresses make it even easier, like Nginx has a native mode that allows it to skip picking the pod and instead just route to the Kubernetes service. So you don't even need to do that annotation. You can just take care of everything directly on your Nginx service. And then we'll have better recommendations with the folks from for Emissary. The Emissary ingress used to be known as the Ambassador API Gateway, as we've been working very closely with the Ambassador folks lately on integrating with Linkerd. So that's kind of the whole demo. I hope I didn't run too long there.
We have a couple of questions,
okay,
if you don't mind answering.
I would love to.
Yeah, so another one from Ramiro from YouTube, actually. Another question I've had for a while. Is Linkerd an all or nothing on a cluster, or is it possible to do a progressive rollout where you only enable Linkerd in a few namespaces at a time?
Yeah, absolutely. So no, it's not all or nothing at all, right? And in fact, one of our getting started demos that we do very often just shows exactly that, right? Like how you can kind of bring it on namespace by namespace. And that's a really common story for customers that adopt us in production, right? Is you can just go through and start enabling one namespace at a time, ensuring that things work, you know, rolling back if necessary and going through. So it doesn't create, like, let me just talk about CRDs really quick, right? So let's do kget CRD. So we're going to look at the CRDs on the cluster, and we're just going to ignore, right? It's grep-v if you want to ignore. I just want to ignore cattle, right? Oops, I should have ignored cattle and flux. Oh, and flagger, whatever. There are two CRDs that I'm not going to keep doing that, extending my grep chain. There are two custom resource definitions that you get with Linkerd, because Linkerd by default uses native Kubernetes constructs. So we have this concept of service profiles, which allow you to get more detailed information about a given service, as well as configure things like retries, you know, specific monitoring, bits like that. And then we have traffic splits specifically for this sort of use case, right? Where you shift some percentage of traffic to another service.
Cool. Can I ask you more questions?
Please do. Yeah.
Yeah. So, well, a nice, fun one. Prathamesh asks, which command line bash tools are you using? It looks pretty with the Linkerd background image.
Oh, thank you. Yeah, so I'm using the Windows subsystem for Linux, right? Because I like to live dangerously. It actually burns me about once a quarter, but I really like it. Honestly, I use the kubectx tools, and I think they're just wonderful. Allows you to switch between namespaces and context really easily. And I've started using this bash prompt modifier called Starship, which is just I'll tell you, I've been delighted ever since I started using it. But it does a great job of allowing you to modify your prompt.
Yeah, I'm a big fan of Starship as well. Andy, you've marked a couple of these that you would answer live. Should I leave them to you or?
No, it's for the talk hosts to answer live. We'll answer them live rather than I will.
Excellent. Okay, so Vinay asks, in our environment, we're using Azure Application Gateway Ingress Controller. Can we use Linkerd?
Yes, definitely. So we'll work with any ingress, right? And Vinay, there's a ton of examples of folks using Linkerd on AKS, right? Like we use Linkerd on AKS as part of our product offering. Man, it works really well.
Cool. And then how about stateful application in K8s by using service mesh? Can it also help in increasing the performance, as Jason mentioned in the gRPC call thing?
Yeah, so it's going to depend on your stateful application. I'm just gonna be real. I'm gonna talk about a couple that I know of real quick. So things like MySQL, Redis, Postgres, probably a few others, right? The way they work, right, is so with HTTP or gRPC traffic, we've got the client kind of initiates the conversation, we get going. Databases often do a thing that we call it internally server speaks first. So as the conversation starts, the server opens up the connection, and they're doing traffic over like their own kind of TCP protocol that they've got, right? And so what we do for that sort of stuff is we basically just treat it as a trunk, encrypt it, and allow data to flow, right? So I would say that in the case of your average database, you're not going to get a performance gain by adding Linkerd. What you're going to get is just that you're going to get TCP level metrics from those applications. You're going to get connection data that you can use, and you're going to get that certainty that you have it encrypted, right?
Cool. And then I think the one that you mentioned earlier from Ganesh. There's actually another question sort of related to from Ganesh as well of like, so the original one was why Linkerd over Istio, and then why Linkerd doesn't use Envoy, and how do things like rate limiting work, and is there a plan for Linkerd to use Envoy?
Yeah. All right. So obviously it's probably pretty clear that I work for Linkerd, right? Or I work for Buoyant, the company that makes Linkerd. So please treat my statements with a grain of salt. I can tell you from the folks that I've talked to, right? Like the thing that people like about Linkerd is it's very performant, it's very simple, and it's very easy to understand, right? And I think depending on your use case, like you're gonna have to pick a mesh depending on your use case, right? Like if you're writing a custom WASM plugin to sit beside your application, then like you need an Envoy-based mesh because that's what it's gonna do for you. Right. And if you're going out there and you're like, man, I want to configure a service mesh and also, debug Envoy filter chains. Right. Great. Like that's Istio's the tool for you. Right. With Linkerd, right, like you're not really going to have to learn about the Linkerd proxy because the Linkerd proxy is just an implementation detail in Linkerd. Right. We think that by being written in Rust, right, we keep the Linkerd proxy like the most secure proxy that you can get out there, right? Because we're able to sidestep a lot of memory management vulnerabilities that you get in C and C++, right? So when you consider, right, like if you're a bank, right, or if you're a healthcare institution, or if you're anyone that has critical data, right, that proxy is sitting beside every single application in your Kubernetes cluster, handling every single bit of sensitive data that transmits it, right? So if you've got a memory management vulnerability that you don't know about, right? Like that's a scary thing, right? And so we think that we reduce the odds of that by using Rust and by doing the testing that the CNCF allows us to do, right? But that's like a judgment question for you, right? I would use Linkerd if you're looking for something simple. You're looking for the basics of a mesh: observability, security, reliability, right? Then it's in my mind the right tool for you, right? But if you have more complicated use cases, then look for other meshes. And obviously, don't take my word for it. Trust your own judgment. And then why we don't use Envoy? Actually, it's a feed into that exact same question, right? So when we wrote Linkerd, right? Well, not like I was there, right? When the folks at Buoyant wrote Linkerd initially, right? They looked at Envoy as the proxy, right? Because Linkerd went through this big rewrite at one point, and so they looked at Envoy, right? And the concern was it would be difficult to adhere to our design principles of being extremely lightweight and being extremely easy to use with Envoy, right? Like Envoy is a great proxy, and I'll tell you all day to go check out that emissary ingress from the folks over at Ambassador, because it is amazing, and it's got a ton of powerful functionality that you get out of that Envoy proxy, right? But that Envoy proxy can also be a huge source of complexity, and when you sit it beside every single application in your environment, you don't just have to become an expert in your service mesh. You have to become an expert in your service mesh and in that proxy, right? Which may or may not be valuable depending on your use case. I hope that answers your question, Ganesh. And I don't have bad things to say about Envoy, and I don't have bad things to say about Istio, right? Like they're both great tools.
Next important question: what do you think of Aeneas's tweet?
I didn't see it. I've been scared to look away.
It's just in the chat if you pull it up.
Oh, yeah. It's how, like, listen, it's how a lot of people feel. Like when I talk to Linkerd adopters, right? Because I go around, I collect success stories from Linkerd folks. So there's a bias there, right? When I talk to Linkerd adopters, I hear people tell me that, they're picking it up on a Monday and they're rolling it into production on a Friday. And they're doing it in that progressive way that, who was it that asked the question? I don't see the name of the chat. Anyway, Ramiro, that Ramiro referred to earlier, right? So yeah, just going to be depending on what you're doing. But I certainly find the Linkerd experience really nice. I'll tell you, I onboarded with Linkerd after previously working for VMware and pitching Istio-based products, and I found the onboarding really nice, right? Because I found it easy to pick up the product and get going and learn some things.
I'm going to ask one last. Well, there's actually a couple that have just come in, but there was a Vijaya Kumar, and this is sort of for everybody here. I certainly can't answer this, unfortunately. Any testing methods for components, including a service mesh?
Yeah, I read that question earlier, and I'll be honest, I didn't really understand the question. So you can obviously test your applications with the mesh. You can test your whole cluster in a holistic way, right? So whatever your current approach is, the nice thing about adding, especially Linkerd, but really any service mesh, is that you can continue to run the same like end-to-end or individual unit tests that you would run otherwise. And then of course, like if you're thinking about app-based testing, add something like Argo rollouts or Flagger, right, to do individual, testing your individual application with the mesh, right?
Yeah, that's a really good point, actually. It's like the mesh is like a component of the whole cluster and clustered architecture, and sort of the way that things play together is that you're almost going to have to do end-to-end stuff rather than testing in isolation of any component.
So Chandan asks if there's a single point of failure. What is the single point of failure? I can't think of one, right? So when the control plane's gone, right, the data plane, those proxies, right, that Saiyam talked about, they continue to talk to each other and function as per normal, right? Yeah, so I guess I can't think of a particular single point of failure. And it's like you can't tell Linkerd, right? Like in the current version of Linkerd, you can't tell Linkerd like, hey, shut down all traffic in my environment. You could corrupt the root CA, like the identity CA that they all use to talk to each other, but that's not something you're going to do accidentally, right? Like you have to know a lot about the system. I guess if I were to think about it, if you could corrupt the root CA or change out the root CA or invalidate it, right, without telling the proxies what to do, like that would certainly cause a lot of damage to your Kubernetes cluster.
Out of interest then, how could you recover from that situation? Let's say something happened and it did get corrupted. How would you generate a new root CA and roll it out?
Yeah, so we've got a doc specifically to talk about how to do that. But what you do, so if your Linkerd root CA has expired, right, while it's live, right, it's basically that situation, right? So what you do is essentially you add a new root CA, you roll all the proxies so that they get a new identity generated off that new root CA, and then you deprecate the old one. So you essentially do 2 rollouts to change the root CA. One to generate all new certificates, all new identity certificates with the new trust root, and one to remove the old trust root from the environment. And then we have a documented procedure on the Linkerd docs that goes through that. And then quick plug for Buoyant Cloud, right? One of the things that it does is give you some notifications specifically about the current state of your certificates in Linkerd.
Awesome.
And then, should I answer this question from, oh shoot, I don't know how to say your name. I'm sorry.
Jiffy.
Sorry. So all service meshes are complex. We only get to know it when something breaks. Onboarding is easy. Managing and understanding logs is hard, and there's definitely a learning curve. If we design it, yeah. So I think Jithu is making the point that, you know, it's easy to get up and running, but it's a lot different to actually productionalize it, which I would agree with you entirely. I would tell you that, you know, certainly from folks I've talked to, they say that the experience running Linkerd in production, especially for folks that have moved from Istio to Linkerd, they tell me that the experience of using it in production is there's a serious difficulty level difference, right? And that one thing you don't need to do with Linkerd is understand, you know, the intricacies of the proxy, right? Which can be a real benefit, right? One of our maintainers, right, recently came on board. He was contributing to Linkerd for months before he even looked at the proxy code, right? Because it's not, like, fundamentally, if you're worried about the control plane, that interface, you're not worried about what is essentially an implementation detail, which is that Linkerd proxy.
Awesome. I think that's the end of the questions. There's nothing more. We've answered everything. There's no last minute ones coming in.
Thanks for joining us, Jason.
Thanks so much for having me. This was wonderful. What a great bunch of folks and what a great audience. I really, really am so grateful for all the questions and everyone that asked.
Yeah, thanks from me as well. Like, we've had some, I think the most questions that we've ever received from the Q&A thing. So it's really cool.
Awesome.
Yeah, there is that last one from Jithu about can you set an order or a delay for the proxy container to come up after the main application?
Yeah, so absolutely. So we actually, so in the latest Edge, we just put it in as an annotation. So you can now put an annotation on your deployment that says, hey, listen, right, like this application is going to come up fast. Don't let it fail until the Linkerd proxy comes up, right? So what we had was a tool called Linkerd await, right, which would essentially, it's a binary that wrapped your install that would wait for the proxy to be ready and then start. Right. What we have now is an annotation that allows you to do that, but without needing to modify your Docker file or anything like that.
Awesome. Ricky, want to give a plug to the next meetup? You know the date?
Yes, 30th of June, same time, 5 p.m. GMT, and it's your one, Andy.
You just give me a major panic thinking it's in 2 weeks and I need to get right in that talk. But
well, you've already written the actual driver, so
yeah, no, it's just making it human understandable.
So the topic next time is going to be around container storage interface, CSI, and things related to that, and sort of
Kubernetes operators.
Yes, yeah, Kubernetes operators, and how we leverage both in the Civo managed Kubernetes offering. Which, if you're watching this and you haven't signed up to Civo, go to civo.com/sign up and do it now, because you'll get $250 credit to try us out.
And if you want to sign up to that webinar, to that online meetup, you can do that right away. Just look up the meetups page at civo.com. It's already up there. You can register so you don't miss out.
Cool. Fantastic. Brilliant. Thank you to all the speakers for your time. Really appreciate you coming on. And thank you to everyone who's attended.
Thanks, everyone.
Thanks all. Bye-bye.
Cheers. Bye.
Bye, everyone.